Okay, my name's Fraser Chadburn. In this demo, I'm going to show you some things about swim lanes in Rhapsody activity diagrams. And I'll just navigate to this activity diagram and show you what I mean. So I've got a bit of double click here working with a Java helper. So this is an activity diagram that just shows control flow with Rhapsody. And you can see how this activity diagram is quite useful for capturing the operational scenario, perhaps of a system, and also how we can link these actions to requirements. I'm just going to also just remove a customization here. So at the moment, the drawing toolbar here has got some additional things here like a derivation, and that's done through an applied profile, which is a profile that, which isn't globally applied, but is applied if there's a dependency with applied profile on it. So I'm just going to delete that, and then I'll reopen the activity diagram. And here I've got the default drawing toolbar for an activity diagram. Let me just expand this a bit. So I've got actions, but I've also got action pins, parameters, and I've got these swim lanes. So the concept of swim lanes is the ability to associate structure to those swim lanes, and then if I put the action inside of that swim lane, then there's an implicit thing within SysML that that behavioral element is done by that structural element. Let me just zoom out, and I'll draw a swim lane frame of roughly the same size as these actions, and I'll subdivide it into three different elements. So this is what we'd call a black box sequence, which is we're looking at the operational scenarios from the perspective of the user, and we're going to treat the system as a black box. So let me just resize these. To be able to resize the frame here, I need to hold down the Alt key, and that allows me to just have some modification of the behavior of the resize. I'll make that slightly bigger. So the first thing is with these swim lanes is the idea that we could associate or get a swim lane to represent a structural element. So here's my first action. The operator logs in at the control panel and activates the teleportation system, because this is a teleportation system. And I'll turn off the hovering toolbar. And I'm going to say, well, that's an action performed by the operator. So within my use case package here, I've got an operator actor. So to represent that actor, I could look at the features and then pick the element, or I can drag the element onto the name of the swim lane. If I drag it here, I just get an object node. If I drag it directly onto the text, it will do that represents for me. This is the swim lane that represents the operator. So if I move this action into that swim lane, and I use the arrow keys here to just shift it across, then what I'm saying is that this action's performed by that actor. Let me delete and redraw the initial flow. I could move it, but generally it's just easier to redraw. So that's the first step. The operator is logged in at the control panel. So the second step here, teleportee tells the operator where they want to transport to, and I'll shift that over with my arrow key on my keyboard, and I'll move that into the second swim lane, and that is an action performed by the teleportee. Something Rhapsody actually does automatically if I have a swim lane, if I look in here, is it will create an inferred relationship, and you can see that's actually an allocation relationship that's been created in the model because of the presence of that action within that swim lane. What I'll also show you then is the ability to see this allocation of behavior to structure within a table. So I'm going to create a powerful concept here called a context pattern table. So I'll create a table layout. Where is it? I'll create a table layout of my swim lane allocations, and I'll go to the features for that, go to the columns, go to the advanced options. Now, not everybody needs to know how to create a context pattern, but they're useful to know what they do and how powerful they can be, so that if you think, well, actually, it'd be really useful to see this stuff in a table, you know that it's possible. Perhaps there's someone in your organization who's able to understand the series of tokens you need to write to create a context pattern. So here's an example. I'm going to say, go to all the packages and any nested packages. Then if you find a use case, then list that. But underneath the use case is an activity diagram, and I'll give that a token name of ACT, which is the SysML abbreviation effectively. I actually then want to have the actions. These are states in Rhapsody. And then I want to see the allocated to elements. So that's go to the allocation relationship and find the end element. So this is a context pattern. If I collapse the first column, I can use the fill defaults to populate columns from that context pattern. The table layout's like a template, so I'll create a view. So this is a table view of my swim lane allocations. If I double click that, we can see that this action is performed by this actor. Okay, let's look at the next things. Operator sets a destination point, teleportee stands on it. I'll just get rid of the input region here. And what I'll do is move across these actions into the swim lanes. Once they're moved across, if I go to table view and do a refresh, here you can see it's representing that. So let's look at the next thing. This is something done by the system. At the moment I've got a third swim lane, but I haven't actually allocated any structural element to it. And often when we use swim lanes, we actually have blocks or parts of the system that we're allocated behaviors to if we go into the white box model. So I'll just create a package with a block in it. So I'll create a design synthesis package. In that, I'll create a block definition diagram. This is a BDD of the teleportation system. And there's a block on it called a teleportation system. And what I want to show with this is also compartments. So firstly, let me take that block and I'll allocate it, or I'll get the swim lane here to represent it. And then I'll move this action into that swim lane. And I'll check that it then appears. Okay, so here we go. We've got an allocation of the system analyzes target location to the teleportation system. If I go to the display options of this block, then what I could do is show that allocation in a compartment. And this is an allocated from compartment is available in the pull down list here. And now I can see the allocation of that behavior to that structural element on my block definition diagram in a compartment using the specification view. In terms of the activity diagram, if I go to the display options of this action, there isn't the ability to do compartments, but Rhapsody does have this call out tool. It's a type of stereotype comment, and if I set the display options to the anchored info on here, and I make sure that box style isn't shown, and I anchor this comment to that action, it's going to pick up the allocated to relationship and show that in SysML callout notation fundamentally. I'll just show you this final thing here. So if I had a call behavior here, which is dematerialize and rematerialize, and I just move that in to a swim lane. Then the question is it the core behavior or the referenced activity that I want to allocate to the teleportation system? Now, if I look at the activity model that's underneath the activity diagram here, you'll see that they're two different things. I've got an activity, which is dematerialize and rematerialize, and then I've got the action that then invokes that activity. So if I want this activity to be allocated to swim lane, rather than using inferred, I actually have to use an explicit relationship to allocate. The right click here would require me to create a dependency and then select that this activity is performed by the teleportation system block. So I'm explicitly creating a dependency here and making that a allocation new term, and that means that it will then also appear in the allocated from compartment. If I had the activity on here, we can see that relationship, and the display options of the activity on a block definition diagram do allow me to put compartments. So that's a quick introduction to the idea of using swim lanes to do allocation of behaviors to structures from activity diagrams, and also some of the support within Rhapsody for inferred allocation that comes from the presence of an action within a swim lane, or explicit allocation, which comes from creating allocation dependencies from the behavioral element to the structural element in this case, and how we can see those either in compartments on a block definition diagram or using call-out notation on an activity diagram. So hope that helps. My name is Fraser Chadburn, and I do a lot of work with customization, specialization of Rhapsody. If you have any questions, then give us a call. Thank you.